Hello, boys and girls. Welcome to the Dow Academy Online Learning. We look forward to seeing you all back in class. But for now, stay home, stay safe, and remember to always wash your hands with soap for at least 20 seconds. Let's begin.
Hello, Form 3s. This is Mrs. Madumbu. We want to continue with the concept of the Pythagoras Theorem. So today we just want to look at the points or the situations to take into consideration when applying the Pythagoras Theorem in problem solving. So we still have our formula in mind. The a squared plus b squared is equal to c squared. So we can use it to find any missing side in a right-angled triangle. So we want to look at the situations that I have here. So in each case, this situation will have a right-angled triangle represented. So it means we can apply it to solve or to find any missing distances. The first one is the concept of a ladder leaning against a wall. So when a ladder is placed against a wall, its foot is placed at a distance from the wall. And the assumption is that the wall will always make a right angle with the horizontal. So the ladder becomes the hypotenuse, while the height of the wall is the opposite side, and the distance from the foot of the ladder to the wall, it becomes the adjacent. So if any of the three lengths are missing, we can use the Pythagoras theorem to find it. Another situation is when we have telephone poles or electricity poles being supported by wires. So in this case, the wire is fixed at the ground level as well as the pole. And the pole is also making a right angle with the ground level. So the wire will become the hypotenuse side, while the pole itself is the opposite, and the ground level is the adjacent side, depending on the given angles. So in this case, we can also use the Pythagoras theorem to calculate any missing distance. In geometry, if we are given a triangle, just an ordinary triangle, but we are not given the perpendicular height, perhaps we need it to calculate area, so we can actually apply the Pythagoras theorem to find it. So as we construct that perpendicular height on a triangle, we are automatically going to create two right-angled triangles on either side of the line. So once we create those two right-angled triangle, if the slant heights are given, we can use the concept of the Pythagoras theorem to find any distance that we want. And in the case of a square and a rectangle, if we happen to draw just one diagonal in each case, the shape is automatically divided into two right-angled triangles. So given the length of the sides, we can always find the diagonal by using the Pythagoras theorem. So in a rhombus, the diagonals actually bisect each other, and so this will automatically create four right-angled triangles. So we are able also to find or to calculate any missing parts using the Pythagoras theorem. But finally, in a kite, the diagonals will just intercept, but they will not necessarily bisect each other, but they intercept, but they create four right-angled triangles. So we can also use the Pythagoras theorem to find any missing parts in this case. So the only situations that we are not looking at now is the concept of applying the Pythagoras theorem in bearing and applying the Pythagoras theorem in circle geometry until we look at those aspects. So thank you for today.